Hello folks, thank you for joining and welcome to Python and R for Data Science. I am your presenter Jason Kinywa, and today we don't have slides for one reason. I want us to do it a little different, and before I kick off today's session, I would wish to apologize for not having kept up to my promise, and please allow me to withdraw my pledge. With the way things are going, I don't think I'll be able to do a video after every 2 weeks. So please allow me withdraw that pledge. But that doesn't mean that now this channel is going to be abandoned. No. I will be committing my time when I have that free time. I'll be committing that free time into this channel and do as much as I can. I'll try and cover as much as possible in a single session, so that now whatever I cover will take care of the period when I will not be able to produce a video. But regardless, be sure we are going to cover everything that was outlined in the welcome video. There is an outline of what we are going to cover in the session of this course. I think we will do all that. The only thing that has changed now, it is the timeline and the pledge to do a video after every 2 weeks. I'll try my best and do a video promptly, but when I cannot, please understand. It's a hell here running errands. I have a lot of projects to take care of in office, and also some other stuff. So please bear with the situation. Back to business. So far we have been doing lots of theories, and today now we are kick-starting the coding part, although I will start with a bit of theory, but from now onward we are going to do more of coding and less of theoretical stuff. So in this screen that is open, this is R Markdown. Don't mind a lot of junks. Okay, don't mind now the those ones that I am going to use for today's session. Maybe in the next session I will let you create your own R Markdown, and particularly you should not even wait until the next session to create your own R Markdown. Open your RStudio and click this plus sign, or there is a drop or down sign over there. Click it. You have an option to create an R script, R notebook, R Markdown. So I chose the R Markdown, and then you get some other options here. Don't mind these ones for now. Just do give it a title and create. Don't customize anything for now. Just create for the sake of following up. But more into that one will come later. So let us begin. What is R? R is a programming environment for data analysis and graphics. This is contrary to what we have been singing and saying all over. Initially, we have been talking of R as a programming language. There is no problem with that, but R is more of an environment than a language. Maybe let that one stick in your mind, but whenever you see us talking of R programming language, just use a programming environment as an alternative to that. We will be interchanging the two: programming language, programming environment. Take them to mean the same thing, although it's not the same thing. So R is a programming environment for data analysis and graphics. This is very important. R was developed with data analysis in mind and visualization of that data set. And I think this will be very important now when we will be bringing Python into the play, because now you see Python was developed for general purpose use, but with R, it wasn't developed particularly for data analysis and visualization, that is for data science. So this guide will give you a taste of what R can do for you, so that you don't over expect and maybe think R can do things that it will not do. So this guide will let you know what R can do for you, so that now you can set your expectations correctly. And to get the most out of this guide, I will urge that you read or you follow while you are doing exactly what we are doing in your own RStudio session. That means at least you should have your RStudio installed, and to install RStudio you need R installed. So please, if you don't have R and RStudio installed on your machine, whichever platform, be it Linux, be it Mac OS, be it Windows, we have produced other videos in other sessions previously, where we have covered installation of R and RStudio on your favorite platform. So if you don't have R and RStudio installed on your machine, please go watch those two videos and follow them keenly to install R and RStudio in your machine. And then when that is done, be sure you are following this guide as you do exactly what we are doing. Open your RStudio. When we type a command, please type it on your RStudio. And even after now we are done with the session, there is no penalty to doing own explorations. There are lots of online resources out there, from YouTube, from Google, PDFs and all that. There are blogs, there are websites. People have committed their time to produce materials worthwhile reading. So please, when this channel use it for reference or for familiarizing or for creating awareness of what R is and what you can do with it, but to get the most, please do your own research and explore the world in your free time. So for today's session, at the end of the session, we expect that you will be able to optimally use RStudio. In our previous videos, we just covered how to install R and RStudio and didn't show you what RStudio is and how to use it. So in today's session, we are going to show you the most important utilities in RStudio and what you will most likely use when you are coding, so that you will now be able to optimally use RStudio. And then next you will be able to document your code for the next session. That is now after the end of this today's session, you will be able to document your code for the next person, and this next person could be you after a month, after a week, after a year, after 5 years. And sometimes if you don't leave helpful comments in your code, you might find it hard changing something or improving something. So this next person could be you after some time, or could be a new teammate in your team, could be another person in your team. It could be a person who is interested in collaborating and contributing into a project. So leaving comments is a good thing to do. And then again, or in addition, at the end of the session, we expect that you will be able to effectively use R data objects. So this session will let you know, it will assist us familiarize with R data objects. So to give you a big picture of what it is, or to create to create suspension in your mind, I will ask a question. What are data objects in R? Or what do we mean with R data objects? That one will be answered, but later. And finally, by the end of this session, you will be able to define and use your own functions. You will write your functions and use them to do some practical exercise. That is for this session, but are we going to cover all this really? I suggest we should not. Why? So that you get to understand. I don't want to take 2 hours in the same video. At least let us go for 1 hour in this video. And in that 1 hour covering all this, I will be denying you the privilege of learning slowly and understanding concepts as they should be. I will assume you are a total beginner in R, and so I'll take time to illustrate the concepts and the ideas very well. And so in that regard, I think let us cover up to the third subtopic. That is, we put a stop at covering R data object, then defining own functions using open source packages and all that. We can do it in another session that that I can do maybe in a week or so, depending now with how errands goes for this week. So let us begin. But before even we start, there is only one prerequisite that has to be met before you can proceed with this guide, and that prerequisite is that you should have R and RStudio installed. So if you don't have R and RStudio installed on your machine, please go into this channel, check there are videos that will guide you in installing R and RStudio in your machine. Once you have done that, open your RStudio, create a new R Markdown, or you create that one below the file icon on your far left navigation, or on your top left, there is a plus icon somewhere and a drop down besides it. You can click the plus icon and it will give you options to create either R script, R notebook, R Markdown. So go for either R notebook or R Markdown. I will suggest you go for the R Markdown. You get a few other options. Don't customize anything. Just give it a title and call it an introduction to R. Then click OK. It will open something like this. Clear everything that comes below the setup chunk. Clear all that. Then wait. I will tell you when to start coding. For now, just wait. Keep your R Markdown as clean as mine is. Keep it as clean as that. And then I let you know when to come back to your R Markdown. Let me cover a few basics, then I'll come back to that later. This is my R Markdown. I have modified it to use a learn R package that enables us now to browse this Markdown in a form of a tutorial page. Let me show you how it will look. This is how it looks. Maybe I can use this one to present the theoretical bit and come back to RStudio when we have covered most of that theoretical stuff. Yeah. Okay. So we have done the introduction. I have explained what R is and all that. Okay. Learning objectives, they are not getting indented as they should be. Let me correct that one, don't worry. Okay. Yeah, the indentation now is correct. Okay, this is markdown, usual markdown. So to get the new line indentation, add a line, okay, 2 spaces after the line, and it will dent correctly. So the prerequisite for this session is R, and RStudio should be installed. And next, open your RStudio. That is by clicking now you're getting into machine menu, open RStudio. If you don't know how to open RStudio, again, in our previous videos, we covered that. So open your RStudio, and when RStudio opens, you will get a console with information about version of R that is installed, license and contributors. And then the last line from that console is a prompt. That sign that now indicates that R is ready and expecting instructions to do. Let me show you what it is. This is the console. So when you start RStudio, it will open an interface like this one, and it will open this console. So the console here will have R version, information about the R version, the license, and the contributors, and a few few guide instructions on how to get started and all that. So it includes an help start, and all that. I'll show you this one in a moment, but for now, this is the sign I was talking about. So this sign here indicates that R is ready and expecting instructions to execute. Yes, that is it. So that is the console. The next thing that is very important for you to note, okay, we covered this plus icon, and then there is this one on your right navigation. Leave the terminal, R markdown stuff, and all this. Okay, this is not important for now. The console is important, the plus icon. And now coming to the right panels, we have on top an environment. This is where now our data objects will be listed. R creates data objects by name, so they will be listed here. More about that one later. History, this is includes everything, okay, all commands that we have been executing in our session. And when you are closing or quitting RStudio, you'll be asked or you'll be prompted whether you need this history and environment in data to be saved, so that now when you come back after some time, when you open RStudio next time, it will not start afresh, but start with the session data and session history. More about that one later. Connections, Git tutorial, leave that one for now. Then coming to the right bottom panel, we have files. This is a list of files in our project, how you create a project. Here on top right, there is a drop down icon. Go for a new project or open a project. Okay, more about that one, I think I will cover this one next when we will be doing some more advanced stuff. But for now, what you need, open your RStudio, create this R markdown and leave it as empty as it is, or alternatively create a project, new project. Okay, this is a prompt because I have some data in my stuff and it wants to create a project, so it will clean my stuff. I don't want to save. I think I can just illustrate. I will not actually create, because creating a project will open, okay, you can create it and open it in another session, don't mind. So go for new project, new directory, then you browse where it will be. Okay, this new project can be an R package, new project, shiny application, and know that just go for new project, an empty project, And then these other options, maybe I will cover them somewhere later. For now, go for new project. This is an empty project. I don't want it here. I want it in my Python and R tutorials. Yeah, this directory. So I add that one. I call it test project. Yeah, give it a useful name, like you can call it a tutorial, a guide, or getting started with R. Getting started with R. Yeah, give it a meaningful name. Then create the project there. Oh, okay. Yeah. Okay, this is the base directory. This is the directory with the project. We can call it R basics. Okay, this is the project name. Oh, I created it in this session. Okay, I'll just open my project again. So this is how it will look when you create a new project. Yeah, as no files. So to add files there, click plus icon, R notebook or R markdown, a new file. So this is an introduction to R. Go ahead, don't customize anything for now. This opens, clean everything below there. Then save your file. Call it introduction to R .rmd .r markdown. Yeah, saved. Then wait, I'll tell you where now to add contents into this your R markdown. Now let us go back to our project and continue the rest of the tutorial stuff. Is this the project introduction to RP6? I don't think this is the project we were working on. Should be this one. Yeah, sure. Okay. Okay, yeah, this is it. So that is how this icon works. That is how you create a project. Next, the plots. When you are doing visualizations, your plots will be drawn here. Don't mind about that one for now. Then it's a very useful utility. Packages. This is a list of all installed packages, so you can load your packages by just checking this checkbox here. You check the checkbox, it will load your package, but I prefer instead of loading your libraries or packages from this tab, you just load them from your script. Why? Because you might want now, okay, you have done your scripting, you have done your data analysis, you have visualized your data, and now you have come back later. You want to repeat the same thing. Coming back and scrolling to each package at a time and loading is a lot of work. So, but by listing here ensures that now you have all your packages in your scripts, so it will not be an headache knowing which package you used and which one didn't you use and all that. So you can use this one now to either load your packages, to install packages, update packages. For now, leave that one as it is. We will cover this one later when we will be looking at open source packages. Then next is the help. This is where now you get help materials. RStudio has actually enhanced this one. What comes with base R is not as good as this one. So when you type help commands here, help, maybe a certain function, let us call it sum, it will open in here, and here you will get documentation details of the sum function included with the base R. So that is it. Also, to browse R manuals, you can now do help.start. This is where you get R manuals, and in particular the most two important manuals here: an introduction to R and R data import and export. These are very important. Please read them, and as you read them, be sure you are practicing them in your R markdown, this one now. So for instance, when you come to vectors and assignment, you read a text, and then there is a code explanation of how to assign a data object to a vector. So create an R chunk here, call it vector object, or vector variables also. That is called an R chunk, and then put your vector data set here. So X, they are called, talking of X equal to C. This is how you create vector data set, 10.4 blah 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 and all that. Then you can preview your vector data set. After you have defined, click this run icon, it will run and output your vector. So while you are reading these ones, please, and I'll insist on that one, please read alongside with your RStudio open and your markdown ready for coding. So you read and do it in your markdown. That is the best way you can do it, and that is how you can get the most out of it. Now see, after we have done all that, our console has changed. Okay, we are seeing a trace of what we have been doing, and when you come again in the history tab, it appears there. So the next time when you are quitting RStudio, you'll see that one at the end of the session. When you'll be quitting RStudio, you'll get a prompt of whether you want to save this data or not. Let me show you this. When you want to quit, you get this prompt. Do you want to save R data and all that? And RStudio, if you say save, it will save this history and R data. So the next time you start the session, it will start with all the session data. But for now, because I don't want to quit, I'll go for cancel. Okay, let us go ahead with this guy. Don't mind that I am jumping from one screen to the other. I want you to understand everything, literally everything. I think having covered up to the head, viewer is not as important for now, so leave it. Those are the most important things that you should care about when you are using RStudio. Yeah. So back to our stuff, back to our tutorial page. So starting RStudio, that is covered. Quitting RStudio, this is also covered. When you are quitting, you get prompts of whether do you want to save R objects, data objects or not. If you say yes, all data objects will be created, or all data objects that were created during the R session will be stored permanently in a file and will be restored in a future R session. When you say no, all data objects created during that R session will not be stored. So the next time you start your RStudio, the session will start fresh. It will not have any session data. Going onward, getting help. How you can get help from R or RStudio. So R itself and RStudio ships with a powerful app utility that can be used to query useful information about any given topic. This topic could be a function, could be a data set or something, an R object that you are interested in. So using this help function, you can get documentation information about any topic. So the first function that you can use to get help or to just read documentation from within your RStudio, it is the help function. This one, you get documentation information about now the topic that is a package, function, all and data set that you specify as an argument. There are two ways to do that. You can either do the function itself or use the shorthand where you begin with a single question mark and then the function name. Then the other one is a pause. This one is used to do a keyword search, and also you do a keyword search. So assume you want to query all functions that have SEQ wordings. So you specify the pattern here as an argument. It will list all functions that have or match that pattern. The other one, it is example. When you do the help function, it will start it will show the whole of the documentation from what the function is, what it does, the arguments it accepts, and then the example. So if you are specific to examples only, you can just go for the example function, and it will jump all other stuff and go directly to the example. Let me show you practically how that is done. The first one is the help function. Then you specify the function as an argument. Say sum. We want to get help about the sum function. Yeah. So this is the documentation about the sum function. The sum function is used to get sum of vector elements, and then it accepts some parameters. The first parameter is numeric or complex or logical vectors. Remove nulls or none, and all that details, and then examples. See. Then remember that one function, this one, the help.start. This is very helpful. It will now give you a browsable website with the topics. This is very important. These are specific to functions and topics, but this one will give you a browsable website. So please be sure you have checked what is in this one and read that website well with your RStudio or your R Markdown open. So read it as you are exercising. The other function was approximate position, pause. Then what do you want? Maybe you say we want to match a pattern. Which pattern? Functions that begin with the word sum. Here they are, them all. Summary, sum. So these are all the functions that match now our pattern. That is, they should start with the word sum. The other one is example. Assume you want to get an example of the sum function, or now we can go for the summary. Summary function. These are the examples. Maybe we need to expand this one, and so these are the examples that come with the summary function documentation. So these are them. So this is for an advanced person who is not interested with all this text. They just want to see the examples and how a certain function is used. Going forward, that is all covered. In R, there are two things: code and comments. So every time you see that a forward sign, this angle forward sign, it means R is ready and expecting commands from you. So you can either add commands. So anything you put after that sign, it is a command and it is assumed to be code. But if that is not the case, you start your stuff with hash sign. So anything on the right of the hash sign is interpreted to be a comment, and that is never executed. R will never execute comments. So how you document your code? Okay, this is markdown, so these are not comments. Don't confuse that. These are not comments. This is syntax of writing R markdown. But when you are writing your R code, so this is my R code. I want to document or write comments about this. So to write a comment, you say this is how we assign a variable to a vector object. Yeah, this is how we assign a variable to a vector object. So this is a comment and it will not be executed. You can also have comments after the code that will never be executed. A vector object, and then here we can see we are previewing our object. Okay, I'll pause for a moment and say something. Yeah, okay, I pose a joke to you. Once upon a time there was a programmer who would never assign meaningful comments to their code. And that programmer is me and you today. Practically, when you are writing comments to your code, you don't say this is a cat when you can see this is a cat. You don't say this is a goat when you can see this is a goat. You write something meaningful. I mean, here, all these comments, they don't stand for anything. Someone who has done a little of R coding knows when you put an object after your R chunk, or when you put it, or when you do a print now your object, they know this is now you are outputting the contents of that variable. So saying here we are outputting that is meaningless. You put something meaningful. I mean, why did you define this object? What purpose does it serve? What do we expect? How about if we get what we don't expect? What should we do, or what should have happened to cause that disparity? Something meaningful like that. Yeah, sure. So when you're defining your comments, please be sure to write meaningful comments. But basically, these are comments and they will never be executed. So the next person who comes after you, and remember I said this next person could be you, a month, a year, 5 years from now, and you are figuring out what was there. If you didn't have code, if you didn't have meaningful comments, then it would be hard for you to figure out why you wrote that code. But with the comments, they will assist you trace back some years back and understand what you are doing, and now you can maybe refactor your code to make it better. So this is how we do it in R, the difference between code and comments. I trust you are following and writing something in your R markdown. Yeah, going forward, that is covered. Now we have covered the introduction bit. That was so theoretical. We take a look at R data object types. What do we mean with R object types? So the entities that R creates and manipulates are known as objects. In other programming language, we will call them variables or data types. But in R, we don't have data types but object types. Yeah. It's nothing big. Yeah, it's just a norm of naming their stuff, but don't get confused. So what R manipulates? They are objects. In an object oriented programming language like Python, an object would mean an entirely different thing. But in R, an object is simply an entity that R manipulates. So a function in R is an object. So confusing. A data set that has been loaded into R is an object. That is a data table, data frame, a table, that is an object. A variable that you define in R is an object. Literally everything that you manipulate or use in R environment is an object. So an object in R is something different from an object in Python. Get that one correctly. Yeah, it doesn't mean the same thing. But an object in Python and an object in C, an object in C++, an object in Java, they mean the same thing. But in R, it is entirely different thing. Get that one correctly. So objects in R are created and stored by name. You create a variable, give it a name, variable A. So the object that is assigned to that variable will be stored by that variable name. Don't get confused. So objects in R are created and stored by name, and function objects or LS is used to display names of those objects stored in R environment. Then there is also RM function that is used to remove objects from our environment. Let us see the so far the object that we have in our environment. We have object LST and object S. LS does the same thing. These the objects that we have created in our environment. And if you come now here to environment, that is very true. We have two environment variables, LST and X. These are objects and these are them. They are created and viewed by name. And then to remove an object, you use the function RM, then the name of the object that you are removing. It will go remove and LST. It goes. Now list objects that are in our environment. We have none. Oh, ls, none, objects, none. That is it. Yeah. Going forward, so these objects, just as we would say that in Python we have various data types, here in R as well, it supports a number of data types, and categorically it has two broad classes. The first class is the atomic types. These are now the building blocks, and then there are derived types. The derived types now, these are all advanced types. These are object types that are built from atomic types. Atomic types, I call them building blocks because now these are the basics, or these are the building blocks for the derived types. Let us see what they are. So atomic types, they are the simplest of objects that you will ever encounter in R. And examples are, okay, they are all 6 in number, and these are logical, numeric, there is integer type, there is complex type, character type, and row type. Let us look at each at a time. Logical type, these are booleans in other language, and they are just two, true or false. Yeah, so this is how you do it. You can define a variable, Okay, we don't have variables here. So when you are assigning an object, you just start with the object name and then the assignment. For instance, we can have FALSE. Okay, we can do something practical here. Let us say kills airplane. Okay, ongoing, the session is ongoing, sorry, the typo, ongoing. This is true, the session is ongoing. Then you can do something, check if the session is ongoing. What should you do? Open your RStudio, open a R Markdown and follow the session while you are following. So if session is ongoing, then what should we do? Print open RStudio. Yeah, let us see. Let us execute our code and see what happens. Yeah, because the session is ongoing, open RStudio and follow while coding. So that is the use of Boolean types. If we change this to false, should be all uppercase, and then they also have their short form. You can either true, T for true, or F for false. Let us use that one. So here we can have else, print, proceed with your normal life. Yeah, don't interpret this one to mean when you are coding you are living abnormal life. So the output changes because now the session is not ongoing. Please proceed with your normal life. Those are logical types. Okay, for logical types as well, you can do something called typecasting. Typecasting is basically moving from one type to another. That is, for instance, assume you end your variable what now other than session. Yeah, on time, prompt. Okay, you can in R you can either use the angle sign hyphen to assign. You can also use equal sign to assign. You can also do assign what you are assigning, prompt, and then the object that you want to assign. You want to assign it true. Then you want to know the class of this. So you can to type a cast from now the string true. Okay, let us just use the full. So this is a string. Anything that is quoted is a string, and in R we don't have strings. We have characters. So the character true to logical true. How you do that? You do a typecast. So tcast. This one is as not logical. We want to cast now that character true to Boolean. So prompt. So now you can also now do print class of tcast. Let us see the class tcast. Okay, let us enclose it in a print function, and also we do print class of now our prompt object. Prompt is a function in R, so we should not use that one. So we can go for ask. Okay, let us say running. running? Is the session running? Is it running? Is it running? Yeah. Okay. So let us see a preview of that. Could not find function as. Okay. Delete one as, leave the other one. Okay. So the tcast, after we do as logical, it comes as logical type. The other one running, our variable running, comes as a string. That is a string type. Yeah, let me expand this plain ground size to about 7 lines of code. Yeah, for ease of saying 7. Okay, let's now do the stuff. Yeah, okay. See? Yeah. Assign running to true. This is a character. Then here we have done a typecast from character to logical. Then you preview the object type. Tcast is type logical. Running is type character. Yeah. Typecasting is very important, not only to R, but all programming languages. The next atomic type is numeric. So, numeric type can be thought of to encompass now an integer, a double, a float. I mean, all numerical variables goes to numeric type, but we have a special type called integer. We will see that one later. But basically, a numeric will take literally anything. It will take an integer 1, integer 5, 10, 20. It can also take a float. Interesting. For instance, assign this variable to 1. So the variable itself is 1. It is not modified to 1.0 and the type is numeric. Assign another variable 1.35. The output is 1.35. That is what is preserved within our environment, and the type is numeric. So numeric type can carry a float or an integer. Let us do an example. example, let's say is 10. Then okay, this is example 1. Okay, let us say this as score. So score 1 and then score 2. Go to 1.2. Okay, when you have this with the numeric type, when you do a mathematical operation to numeric type, the output will be a numeric type. Let us see total equal to score 1 plus score 2. Let us see class of total. Yeah. See? The output is a numeric. Assume it was at times. All are divided by same thing, numeric. It's not because of this decimal point, because we could also have a 5 there, so both are integers, but the type will remain numeric because these are numeric values. And by default, when you assign an object without specifying the type, it will come as a numeric. But now when you come to integers, to denote it is an integer, there is a postfix of L, so it is either 10L, 5L, that will be now denoted as an integer. For instance, let us say score 1, now it is 10L, and score 2 is 5L. So total equal to score 1 less score 2. So what is the class of the output? Total. Okay, let us see. Integer, that is the output. What is the class of score 1? Integer. Score 2? Integer as well. So when you are doing mathematical operations to a common object type, the object type will be preserved. But assume now we are doing a mathematical operation between an integer and a numeric. To convert it to a numeric, it's simply you delete the postfix L. Let us see. Score 1, that is an integer, and score 2 is a numeric, and total is the output of now the mathematical operation between a numeric and an integer. What will be the class of the total? A numeric. Yeah, I think that is very important to take note of. When you are operating between data types in R will take the most general type. Assume we were doing an operation between a character and a numeric variable. What will be the object type of the output? You know the answer? We will find out later when we will be looking at the character type. But I will always take the most general type and assign it now to the output. Okay, that is very important when you are dealing with big data set. Assume you didn't want to mess up with your data, you want to preserve your data set with the most or optimal accuracy possible. So if you end a column of type float and you have another column of type integer, you want to create a calculated column based on these two columns, numeric or float and an integer. To preserve your data with the precision it has, the output should be the output column should have a type that is so general and includes all. So definitely to preserve now the precision, you can be sure now the output column by default it will be a numeric. But if you specify otherwise, or if you now cast your output column to an integer, you lose now the data accuracy. Important to note. Yeah, very important. So then there is a complex type. When you do a square root of 12, square root of 13, you can get a square and a complex part. Remember we said R was created with data science in mind. So they knew there is such a type, complex type. So it is part of the atomic types in R. And then there is a character type. In R we don't have strings, we have characters. So R, this is a character, 6 is a character, false in quotes is a character, 56.87 in quotes is a character, and orange or a boy went somewhere, that is a character, not a string. We don't have strings in R. And also remember typecasting. You can move from char1 equal to 56.78. Then you can do, okay, let us define it as a character, and do a typecast. Cha1, okay, Cha2, we do a typecasting as not numeric, and then this is Cha1. Then let us see print class of Cha1. This should be character. Print class of Cha2. Okay. Let us see one call done. My hand session has jumped. It does no longer. It has said, I am not going to execute your code. You have errors. Damn. Why? Okay. Please be kind to me. Please, 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 please be kind. Okay. See the first character. Okay. This one, the object defined with the quotes was given type character, and the other one text type numeric. We have done here. We are doing a typecasting. Then let us do another. Let us do something else interesting. Assume we want to add the two. Result is character 1 add character 2. Yeah, this is mad. We are adding a character to a numeric, or a numeric to a character. Let us see the class of the output. So print class res. I'm fond of forgetting that, closing parenthesis, print class of not class, no, let us print the actual object, that is the results object. Execute that. Now numeric argument to binary operation, that is not possible. So to be able to add the two, you should either convert one to a gun type. That is, if you are adding character. Okay, we can now maybe now typecast as not numeric. Yeah, you should cast this one to a gun type so that you can be able now to do mathematical operations to it. Yeah, that is this. You are able to do that. Then last but not the least, we have the row type. The row type, now this is where we store now everything as row. That is now in binaries. For instance, an orange is stored as this one. An atomic type will be stored as this value. Don't mind about this one because we will more or less use this one. The row type, not I don't see a use case where we will use it. And then next, I think we should be looking at derived types. These are deep, and so far we have done an hour session. So I think let us put this one for the next session together with data input, import, export, writing our own functions, and using open source packages. Yeah, let me have that one done in the next session so that they are done slowly and in depth so that you get to understand everything. I mean, you should understand. This is, if you don't get these basics, then going onward it will be very difficult for you. So I don't mind spending much time here to lay a good foundation, because now you see doing analysis, doing data analysis, processing your data, visualization, all will depend on how better you understand these basics. So I don't mind spending a good time here to leave foundation for now the advanced stuff. Yeah, this is very important. So for these types, the derived types, I'll cover them in the next session, together with how we import data into R, how we export data from R session, how we write our own functions, how to use our own functions to do some stuff, and then now installing and using open source packages. So for today, allow me to stop at that point, but before we call the session to conclusion or to an end. Okay, this note: missing values have a special type, null, and none. These are special types that you use for missing values, and none is equal to the other. Null is a special value which is not equal to null, which is not equal to none. I'll tell you the differences between them in a little video. For now, I think as a closing remark, I would want to bring it to your attention that we have a GitHub repository where now you can get code materials that we will be using for the tutorials or examples and everything. For instance, this markdown that I have been using to illustrate today's guide, it is here in the tutorials repository. All code is there, and everything will get into this repository, including code and all that. So these are the R basics. So this is today's session, the R markdown file. That is it. Please take your time to go through it, and let us meet now in the next session. Thank you very much for paying attention to this far. I appreciate your time. Thank you very much. Let us meet in the next session that will be done in less than a week, and that is where now we are going to cover the derived types, writing own functions, and using open source packages. Thank you guys. Thank you very much. Bye.